Hey everyone, welcome to Coding Simplified, and today we'll see a very important problem in DP. So basically we are given two strings. We need to find the longest common subsequence length, right? So if you see that here in this string we have ABDE and in this string we have ACBEF, right? Now if you see that first of all we need to identify the common subsequence, right? Because you need to understand the difference between common subsequence and common string. Like let's say if this problem was something like this, ABDE and ABDFE. Now in this my longest common substring, my substring would be this one BD, because like ABD, because this is the longest common substring we have, common substring. But here we are talking about the common subsequence. So sequence, it's not necessary that in subsequence we should have the nearby character also same. We can jump the characters as well. So like if you see here we have A, B and E here. Similarly if you see here we have A, B, E. So in both the strings this ABE is the longest common subsequence we have, right? And what is the length of this? The length is 3. So it means our answer should be 3, because this is longest common subsequence we have in both the strings, right? So now as we have understand our problem, so let's start with the basic problems. So let's say if my first string is AB and my second string is let's say we have AC. Now in this case how many common subsequence we have? We have only one common subsequence, this A, right? And take one more example. Let's say we have one more sequence here, AB, and another common subsequence is CB. Now here also we have one common subsequence, right? Because we have only one character which is matching. So first of all take this one. Now if you observe this, can I say that I will start from the last character of the both the strings, and if last character matches, then I can say that it means that these characters are matching, right? It just light here, it says these characters are matching. It means I need to calculate the rest elements, right? So can I say 1 plus, and then again you check. So let's say I have longest common subsequence, I will again check whatever the remaining element we have. So let's say if the length was here n-1 and the length is m-1. So if the last elements are matching, then check for the other element. Similarly, let's take one more example. Let's say we have A, B, C, and here we have E, F, C, and I want to check the longest common subsequence length, right? Let's say this is also AC, this AFC and there ABC. So longest common subsequence length is 2, AC. So I will start from the last character. I will check if the last characters of the both the strings are matching, then it means 1 plus, check for the remaining. Check for the remaining means AB and AF. Is it correct? Yes. Then again it will check further that if last character is matching, then do 1 plus this. But if last character is not matching, then what you will do, right? Like this example. Here we have AB and AC, right? So can I say that if last character is not matching, then whatever will be the maximum of LCS of A and AC and LCS of AB and A, means if you see, then I can have two things, either A or AAC, because I know that this character is not matching. It means I need to find the maximum characters matching, maximum longest subsequence out of this one, or I can have the complete this one, right? And whatever will be the answer, I will get the maximum out of that. right? So like this one, here my last characters are not matching, right? So what I will do, I will say okay, your last characters are not matching, that is fine, but whatever the maximum of this one, find out the maximum of this one, or you can have this one, right? Then whatever is the maximum longest common subsequence, that you will be your answer, right? So it means what we have figured out, that will solve the question recursively, and we'll check that if we'll start from the last characters. If last characters are matching, then we will do 1 plus LCS of the remaining element in n-1 and m-1, because last characters are matching. But if last characters are not matching, then I will return the maximum of LCS of, first of all, n m-1 and LCS of n-1 and m, right? So this will be my answer. So now focus on the original string. Here we have A, B, D, E, and here we have A, C, B, E, F. Now we say that check for the last characters. If last characters are matching, it's not matching. It means we need to identify the maximum out of either of this one, n m-1, or either n-1 m. It means there will be two things. That first of all, find the whatever the value of the A, B, D, E and A, C, B, E, because I am not taking this F. So either will be, this will be one value, and here I will have another value A, B, D, and here I will take A, C, B, E, F. A, C, B, E, F. So here basically we have B. So what is happening, that I am taking that a maximum of n m-1 and n-1 m. So here when we took n means exactly length and m-1, so we decrease one element. Similarly here we did n-1. n-1 means remove the one element. So whatever will be the maximum out of these two, that will be my answer, right? But here again, now I will check. Now I will operate on this one, because this is my sub problem now. So I will check that whether the last elements are matching. Yes, last elements are matching. It means that 1 plus, I need to find the 1 plus of the ABD and ACB, right? Because last elements are matching, so we check that if last elements are matching, it means you need to find the n-1 and m-1, right? Now again I will operate on this one. So here my last elements are not matching. So if my last element are not matching, again it will go further, and it will have two conditions: either check A, B, D and in AC, or check between AB and ACB. So whatever will be the maximum out of this one, that will be my answer, right? Now again I check that this will again go further. Now D and C are matching, no. So again it will go further, that here I will have A, B, D and check between A, or here you will check between A, B and AC, right? Again it will go further, and here it will have A, B, D, either one, and or because there is no such length, so if we decrease -1, it will be 5, means no length. So let's say it 5. Or I can have something like this, A, B, and here we have A, B and A, right? So here we have 5. So if this is 5, then what we can do, that if it is 5, it means there is no such common subsequence, so it will return 0, right? And here we have A, B, A. So what will happen, this will again go further, because here B and A are not matching, so it will go further, and one will be A and A, and another one will be A, B and 5. Now this is maximum of this one, so this is A and A, means matching. It means it will return 1 plus, and because it is 0, so it will return 1, and this is 5, so it will return 0. Means what is the maximum of this one and this one? The maximum is 1, right? So it means this value will return 1 here, that one elements are matching. Now here it is returning 1 and it is returning 0, it is returning 1. So what is the maximum? Maximum is 1. So this one will also return 1, right? Now this will go again further, right? Here we have one case which is AB and A, and or it will break A and AC, right? Again it will go further and it will have A, one case will be AA and one case will be AB and phi. So this will return 0, it will have value 1, so it means this is 1 0, so maximum it will return 1. Now similarly it will also break, right? 1 it will break in AA and 1 it will break in phi and AC, right? So it will basically return, it will have value 0 because this is phi, so it means no value is matching, and here it will return 1. So maximum of out of 1 and 0 is 1, so it will return 1. Now what is the maximum of 1 and 1? So both are returning 1, it means it will return maximum is 1. So if you see that this is also returning 1, that one sequence is matching, this is also returning 1. So it means it will return the maximum of 1 plus 1. So it means it will return 1. So if you see, the ABD and AC is returning 1, which is also correct because here we have only one sequence matching, right? So this is returning 1. So now here ABD returned 1, and now we'll also operate for this ACB, means this portion, right? So now this is how it will keep on doing the solution. This will do for this one. Now this will do similarly, it will operate for this one, right? Now this was the long example, but let's say if I'm talking about the just basic example, let's say AB and AE, like what's the common subsequence in this? So common subsequence is 1 because we have only A. So how it will break? It will have two cases, either it will have AB and A, or it will have A and AE, right? Again it will break in two because this is not matching, so either it will have AB and phi, or it will have A and A, right? Here it will have again two cases, A and A, or it will have phi or AE. So because here we have phi, so it will have 0, and here it will have 1 because here we have A and A, which is matching. Now 0 and 1, what is maximum? 1. It means it will return 1. Here also it is matching, so it will return 1. Here it is phi, it will return 0. 0 and 1, what is maximum? 1. Now this is also returning 1, this is also returning 1. So what is maximum? Maximum is 1. So it means overall it will return 1. Right? So it means if you see, this is something like this, that this here we have S1 string and here we have S2 string. L1 is the length of this S1 and L2 is the length of this S2 string, right? Now I'm checking that if L1 is 0, means if first string is null string, or if L2 length is 0, it means this is also a blank string. If both the strings are blank, if any string is blank, then I will return simply 0. So this is basically phi. Phi means this is blank string. Now I'm checking, I'm starting from the last character. I'm checking that if L1 minus 1 equals to L1 minus 2, right? Because why we are doing this? Because this was the length. So we always get the character minus 1 because we start from the 0. So we say that if S1 dot character at this index is equals to the character at this index, then do 1 plus then L1 minus 1 and L2 minus 1, because I am going one by back and I will recursively again call. And if it is not the case, then get the maximum of the, so first of all I am getting L1 minus M and L2, and you will getting L1 L2 minus 1, right? And if you are confusing with this N, so let's just consider this M N. So the first string is of N and second string is of length M, right? So you can see that I'm checking N minus 1 M and I'm checking N M minus 1. So whatever the maximum, then it will return this one. Otherwise it will return N minus 1 M minus 1, right? So this is the same thing that we are doing here, right? So if you talk about the time complexity of solving this question, right? So basically what I'm doing, that if you see here, we are doing two recursion parallelly. This is one recursion and this is one recursion, right? So my overall time complexity will be 2 raised to our n. Let's say if it has n length or n length, but if it has n length and this is m length, so I will do n plus m, right? But effectively we say that our time complexity is big raised to our 2 raised to our n. So this is my time complexity. So now if you see, now it comes the important point, that can I apply dp here, right? So dp says if you have these two properties, then you can apply the dp here. First of all, it should be overlapping subproblems. Then let's see here, that was there any overlapping subproblem. So if you see here, that here also we solved for this one a, b and a, and here also we solved for this one a, b and a, right? Similarly, if you see here, so many times we solved for this one a, right? So it means if you see that, and this was only for this one, when you will solve for this one, there will be again subproblems. When you will solve for this one, there will be again so many subproblems. It means there are so many subproblems that we are solving again and again using recursion, right? It means first property matches that there are many subproblems. Now it comes another property, that if this problem is following in this optimal substructure. So optimal substructure says that if you have the solution of the subproblems, then can you achieve the solution of the final solution, right? So let's say of this one. Now if I have the solution of the till here of the last value, then can I achieve this one? Yes. So that's what we are doing here, that if I have the solution till here, then I will just add 1 plus this one. If I have the solution of the maximum of this one, then I can directly get the solution of this one. So yes, here we have this property also, that if we have the solution of the subproblem, then I can achieve the solution of the final solution. So it means both properties are matching here, so I can apply dp here, right? So in dp we basically solve using two approaches. One approach is top to bottom and another approach is bottom to up, right? In top to approach, what we do, we basically solve in the same manner, in the recursive manner, but it's just that whenever we are able to find any solution, we just store that value, right? And we check, and whenever this problem again comes, we check that do I have solution for this problem, and if I have solution for this problem, then I just get from this and then I return that value, right? Now what will happen like this case? So once it will check for this one, that we have already found out the value of the a, b and a, right? So it will check. So when we'll again finding out this one, it will check that do you have the solution for this a, b and a, and if I have the solution, then I will get from the value and I will just return the value. So that's what I do in top to bottom. So as we also saw in the Fibonacci problem or like LCS problem, that what we do, we basically store the values here, right? Now in Fibonacci series, we took the array to store the value, and whenever the new problems comes, we just check from the array that whether the value exists or not. Now we need to find out that how we can storage the value here, right? Now because here we have two strings, one string is s1 and another string is s2. Now can I solve this problem? Can I store the value using array? Now using array it will be little bit difficult, so basically we need to store the value in matrix form or like in 2D array, right? So like let's say if I'm talking about this one, only this problem, here we have AB and let's say I'm talking about AC. Now in AB and AC we have one value which is matching, so I can easily represent this one using a 2D array. So basically let's say here we have AB and here we have AC. So now when I'm operating this row, when I'm operating this row, so first of all, when I'm operating this row and this column, so it will basically check that whether AA, how many longest consequence in this one. When I'm at this here, so it will check how many common subsequence between this portion, A and AB. When I'm at there, when I'm solving this column, it will check, this we have already covered, it will check how many longest consequence between this one. And when I'm operating this one, so it will check that how many common subsequence we have between this one, right? So the 2D array will be the best one to solve this question if I am doing using top to bottom solution, right? So to store the value, we basically take the 2D array. So in top to bottom, what we do, we basically solve in recursive manner. It's just that we store the value whenever you are finding out the solution. So we will modify our recursive solution. So in LCS top to down approach, we basically modify the earlier recursive solution, right? So the difference is that we'll store the value, right? So for that, what we did, we basically initialize an integer array, right? And rather than basic integer array, we are basically defining the integer class array. So what will be the benefit of choosing this? The benefit is that, let's say if we are just choosing the integer, normal integer one, so in that what will happen, that our value will be initialized with the 0, right? And it can happen that both the strings have 0 length. So in this case, it will not be that suitable to match. So that is why we are initialized with the integer, because this will basically initialize the value with the null, right? So we can easily check that. Now what we do, if you see here that this is the base condition, so this is same, that if n equals to 0 and m equals to 0, then return 0, which was also same in recursive solution. Now what we are doing, we are saying that if we haven't found out the value, that if array of nm is null, it means you need to find the solution. So look, the same thing we are doing here, what you are doing in the recursive solution, that we are saying that if last characters are matching, then do 1 plus LCS top to down and do the same thing. And if values are not matching, then find out the maximum of the same thing what you are doing from here, right? The only difference is that here we were just returning the value, but here we are storing the value. If you see here, we are storing the value, right? Here also we are storing the value, and then we are returning the value here, right? So what is the benefit? That whenever the same problem will ask again, then it will check that whether this is null. So in that case, that value will not be null. Then we can directly return from here, right? So that's the benefit of a DP here, and that's how we solve top to down approach, that we basically store the value so that it doesn't ask again, right? Now if you talk about the time complexity of top to bottom approach, so basically what we did, that now we are not repeating it again and again, right? So if we have the n length in the S1 and if we have the m length into S2, so effectively we are solving in n cross m. So this will be my time complexity. Now if you talk about the space complexity, so because we are taking an array, so if there are n element in first string and if there are m element in here, it means we need to solve for all this. So it means my space complexity will also be n cross m, right? So this was about top to bottom DP solution. So now let's see the bottom up DP solution. So the difference between top to bottom and bottom to up is that in top to bottom we always start from the top and then we go till the bottom condition, right? But here in bottom to up we always start from the base condition, that what's my base condition, and then using the solution of the bottom solutions, the base solutions, then I reach till top solutions, right? So that's what I have in bottom up. So here basically we'll use the same notions, same logic, that if my value is matching, so I will do 1 plus the remaining of the both elements, right? And if my value is not matching, so I will get the maximum of the n m minus 1 and n minus 1 m, right? So what I have done, basically here also I have taken a 2D array. Now my first string will define all the row element, right? And my second string will define the column element. So what's the point? The point is, that when I'm iterating of this one, because look, my point is to check for each and everything, right? So when I'm operating for this one, it means this first value is checking all the cases here. So first of all, it is checking that when I'm here, so it is checking whether A is matching with this phi. So why this is phi? Because I'm using the base condition also. Let's say if this s1 is phi means blank string. So in this case, my base condition will be that if it is a base condition, if it is a phi, then what is the common subsequence between phi and A? 0. Common subsequence between phi and B? 0. Similarly here also, that what is the common subsequence between phi and rest element? 0. So it will be 0, 0, 0, 0. So we always initialize a 2D array of the length n plus m, n plus 1 and m plus 1, right? So why this is phi? Because we want to check the root condition also, that if your s1 is blank string and your s2 has some element, right? Now my point is, so what I was saying, that now I want to check A with each matches. It means I want to first of all check with AA, then I want to check with this A and AB, then I want to check with A and ABD, then I want to check with AABD. So the same thing is happening here, that when I will operate for this AB for this one, so it will represent this one. First of all, it will check with this AA, then it will check with this AB, then it will check with this ABD, and will check with ABDE, right? So now we start for this index from this row. So we'll start from the 0, 1, 2, 3. 0 because that is default value. This is for the null blank value. So we have already seen this will be default. So we'll start from this I equal to 1 and we'll check one by one. So now check whether this A and R matching. Yes, they are matching. It means 1 plus whatever the n minus 1 m minus 1. So it means my n is 1, m is 1. It means check this A0. So whatever is the value of A0, this will be 1 plus A0, means here. So it means this will be 1. Now check that whether A and B are matching. No. So it means when I'm effectively doing for A and B, it means I'm checking for this one, A and AB, right? Then check that A and B are matching. No. It means whatever is the maximum of the, so my n is, this time my n is 1 and my m is 2. It means I want to check for 1 and check for 0 and 2. So 1 and 1 means this one, and 0 and 2 means this one. So what is the maximum out of this one? Maximum is 1. So it means what we are doing, if my value is not matching, so I always check with this one and this one. So like when I'm operating this one, I will check this one, and if my values are matching, then I will do 1 plus of this value, right? So like this one, A and D are matching. No, it means maximum out of this one. So this is 1. A and E are matching. No, it means maximum out of this one, this will 1. Now check for B. So when I'm doing for B and A are matching. No, it means maximum of this one, this will be 1. B and B are matching. Yes, matching. So when I'm doing B and B, it means I'm checking for this AB and AB, because I am here B and I am here B. So this is matching. It means 1 plus of the diagonal value. So means 2, right? So look what I'm doing. I'm doing bottom to up. It means if I want to calculate only this one, my solution will be 2. Now check with this one, B and D. So when I'm calculating for B and D, it means effectively I'm checking for AB and ABD, right? So the maximum out of this one, this is 2. Now check for B and E. The maximum out of this one, this is 2. Now check for this one, D. So D and A are matching. No, it means maximum out of this one, 1. Now check this, B, D and B. So maximum out of this one and this one, maximum is 2. Now check D and D. Now this D and D are matching. So whatever is the diagonal value plus 1, it means 3. Right? So effectively when I'm checking with this ABD, I am comparing with this ABD and ABD. So this is 3. Right? Now check this D and E. So D and E are matching. No, it means maximum of this one and this one. So this is 3. And after that I will just return this one. This will be my answer. right? Take one more example, basic example. Let's say I have s1 equals to a and my s1 equals to ba, right? It means only one matching, so this will be phi a and here I will be phi ba. So this will be 0 0 0 and here it will be 0. So I will check a and b are matching. No, it means maximum out of this one 0. A and a are matching, so it means whatever the value of this one, 1 plus this one, so my answer will be 1, right? So this is how I am solving the bottom up DP solution. I initialize an array and using this basic approach I am keep on solving the problem, right? Now if you talk about the time complexity, so basically what I'm doing, that I need to operate if there are n element and if there are m element, so I need to operate for n and n cross m element. It means my time complexity will be n cross m. Now if you talk about the space complexity, so because I am using an 2D array, my space complexity will also be n cross m, right? So this will be my solution. Now let me show you through code as well. So this is bottom to up. So what we did, this is a basic approach, that if L1 equals to m 0, and let's do it, this will be n and this is m. So my first string of n length and my second string of m length. Now I'm doing that if n equals to 0 or if m equals to 0, then return 0, right? Else you initialize an array with n plus m and m plus 1 value. Why plus 1? Because I want to check for the blank string as well, phi. Now you start from the I equals to 1 and j equals to 1, and you do the same operation, that if your values are matching, if your I minus 1, if your s1 dot character at I minus 1 and j minus 1. Now why I minus 1 j minus 1? Because I'm starting from the phi, right? So that is why I need to do for I minus 1, right? So that's the point. Now I'm doing, so if values are matching, then you do 1 plus I minus 1 j minus 1. So look, here we are checking with the string, but here I have this array. Now if the values are not matching, then you get the maximum out of I j minus 1 and I minus j, right? And at the last you return n m, array of n m, what you want to find out. So that's all regarding this video. At the starting we saw the logic, that how we can solve this question. Then we saw that there was overlapping problem and optimal substructure property. So it means then we applied the DP. Then we saw the top to bottom approach, and at the last we saw the bottom to up approach, right? So that's it. And if you have any doubts regarding this, please write in the comment section and I will try to explain that. And I will also put the source code into description, so if you want, then you can also get it from there. So thanks everyone, and if you have liked the video, then please like it and subscribe to the channel for more such videos. Thank you.